So let's look at this question here, which was taken from the year 2019 ASRJC paper 2 question 6. I believe this question is on normal distribution. So birth weight can be used to predict the short and long-term health complications for babies. Some study shows the birth weight of the babies born to mothers who do not smoke in a certain hospital is given by this. It's a normal distribution. So the hospital classifies the baby here. Now, sample show that 20.2% of the babies born to mothers who do not smoke have low birth weight. If this is true for the entire population, find the possible values of sigma. Okay, great. So you have got do not smoke, have low birth weight. So I'm just gonna let x be the weight of babies for randomly baby born to mothers who do not smoke. Okay, that is a important part. So this is x in this particular hospital. So I'm going to name this as x normal distribution, and then after which you have a mean of 3.05 and sigma square. Okay, so the hospital classifies based on their birth weight as shown in the below. So the sample show that 20.2% of the babies born to mothers who don't smoke have low birth weights. So here, this is low birth weight. Just here. Basically, this class here. If this is true for entire population, find a possible value of sigma. Explain clearly why one of the values of sigma should not be rejected. Why one of the values of sigma should not should be rejected. Okay, great. So in other words, this case here, we know that P, this is 1.5. So you're going to put this as P 1.5 between X and P between 2.5. This will give us 0.202. Okay, that's 20.2%. So this case here are pretty okay, I feel. What we need now is essentially just key in calculator. I think calculator work would do, because now this is 0.5 minus 0.202. And this is 0. Just key in calculator here. Just refer to our notes in the normal distribution, which how to key this in calculator. I'll just go through very quickly. This is normal CDF. The lower boundary will be 1.5. The upper will then be normal CDF. This will be 1.5. The upper will then be 2.5. And mu would be 3.05, and after which this will put x, right? Yeah, then you just minus this as minus 0.202. Okay, so key this in the calculator. Now, of course, if you're going to just zoom standard, you'll see weird stuff like that. But what I will say is just put, because sigma is a positive number, so I'm just going to put this 0 to 20 because I can see that it cuts at the very end there. And this one, just y min, y max, just put 1 and negative 1 and 1. Because you're dealing with probability, it's good to just put it here. So this is the answer that you're looking at. So it's sort of like is this portion here, right? So I'm going to zoom box in this portion here, so you can see whether I get my answer there. Okay, so this one here, zoom box here. Okay, enter. There you go. So these are my two values here. So calculate it, and I'm going to place this as 0 and just calculate these two values here. So one on the left and one on the right. So one on the left here will be 0.697. So from GC, sigma will be 0.697. 0.697. This is the SF. Okay, or the other side, which is 0. This will be 1.5599. So 1.5599.56. Okay, so these are two values there. Let me just copy the graph out. So this is it, but what do we want? We want in 2 decimal places, so I'm going to write in 2 dp here with 0.702 dp. Or, oh yeah, 1.562 dp. Okay, now that's great. Now once done, let's look at the subsequent one, which is actually explain clearly why one of the values found should be rejected. Okay, so one of the value found should be rejected. Anyway, you try to understand this. The normal distribution now is given by x, either x normal of 3.05. This is n I 3.05, right? So one is like 0.70 square versus x normal distribution of 3.05 1.56 square. Now the key thing here is know that what do you call it? This is one standard deviation away. Now remember, one standard deviation away from the mean is actually what do you call it? One standard deviation away from the mean would actually be 68, roughly 68% of the population, right? So this is a huge spread here. That's very important. This one not so much. I think this is more realistic in some sense. This case here, if you are going to compare, you can just compare this. I'll put this as a px. I'm going to find if it's realistic or not. I'm going to find baby with the weight of less than 0. Okay, that is the important part. So if when sigma is 0.7, okay, because this spread is so huge, I think very likely this needs to be considered out of the picture. So if you take normal CDF and you put give me this distribution normal CDF negative 10 to the power 99, and then you put the upper as 0, then after you 3.05, the first one is 0.70. This will be, you enter it, this is actually 6.59 times 10 to the power negative 6, which is actually very small. 0.0000659, which is roughly 0. Whereas if you take sigma equals to 1.56, so px less than 0, let's just try and do that and see. This will be 0.70, this is 1.56. I think you get 2.5%. 2.5 2.8. This is 2.5%. Okay, this is a lot. Okay, 2.5% is a lot because so this needs, so hence this needs rejected. Hence sigma equals to 1.56 needs likely should be rejected. Should be rejected. Okay, that is very important because the spread is so big that you will go to the negative region, right? So like, okay, since when px less than 0, this is to say, right, for this part here, this is to say that for every 100 babies born, 2.5 of the babies on average, for every 100 two babies, 2.5 babies have a weight less than 0 kg. That's a lot. Okay, so that is not something which you would expect. So okay, so that's how you do this part here to see whether it's realistic or not. So that's how you do this question here proficiently, and any question at all, please let me know and I'll see you in the next question.